Hello everyone, this is Dr. Shabina Sayed, Associate Professor in Karmavir Bhaura Patil College of Engineering, Satara. Today I am going to discuss about the thin computing, that is a green IoT under the environment sustainability as a part of submission of my course International FDP on Environmental Sustainability OE4BW. As this part of submission, I already uploaded my two videos on first on green computing, second on green internet of things. How this green computing plays a very important role in environment and sustainability. So this is I already discussed in my previous video about this green IoT. So this is just only a brief summary how this green IoT plays a very important role in environment and sustainability. Now what is the outcome of these videos? This outcome of all these three videos are describing the importance of green computing in achieving the environment sustainability. Analyze the difference between CO2 emissions and carbon footprint in usage of thin client and normal desktop. Apply the green IoT solution for environment sustainability. Apply the recyclability solution for computational sustainability. This is the main outcome of all these three videos. Now let us move to the ISO standards of green computing. There are mainly three standards that was published in the year 2015, 2016, 2019. ISO 14001, ISO 14004, ISO 1400. So these standards plays a very important role in achieving the objective of the standards. The objective of standard is to improve your environmental performance with this family of standards, general guidelines on the implementation, and guidelines for flexible approach to the phased implementation. Now let us move to the IoT guidelines for sustainability. So IoT, as I already said that IoT is one of the application of green computing. So it plays a very important role in environmental sustainability. So as far as the guideline is concerned, it provides the structural incentives and to encourage the prioritization of sustainability objective. There are various objective has to be designed, and the action has to be decided by the government, private sectors, and there are various key opportunities also there, and there are some key risks. That is, the sustainability continues to be an accidental afterthought. So this is some few guidelines that I have described here. Next guideline is integrated technologies, and next guideline is address infrastructure, and next is a simplify legal framework, how it is to be experts to enhance the pace of the IoT deployment and reduce the risk of political cycles. Establish the data governance terms for ownership. Exercise the flexibility in designing. Develop cross-industry solution to unlock the mutual benefits. Achieve scale by demand consolidation, and embrace a sustainability awareness culture to respond to new generation. Adopt a framework based on UN Sustainable Development Goals, and last is identify potential sustainable development goals. So these are the sustainability continues. The risk is to sustainability continues to be an accidental afterthought. The maximum sustainable development impact of IoT projects. So whatever the IoT projects we are consider, it is maximum. It is a sustainable. Now this is the role of the IoT in environment sustainability. Now let us move to the thin computing part. So as far as that, I already discussed in my previous video what is about what is mean by the thin client, and what are the thin clients has to be used in any organization. Thin clients are small silent device which communicate with a central server to deliver a computing experience to the user that is largely identical to that of a PC. Now that is to be considered in the thin computing. So thin computing is the combination of a data center that stores controls and or execute controls and or execute the applications, and a thin devices that display the results and handle the processing for certain tasks like multimedia and sound. So in this diagram it is clearly indicate that how these thin devices has to be used under the thin computing. There is IP camera, mobile clients, uh, and or monitors. All these are connected to the servers through the switches. So the criteria that is to be required for environmental benefits of thin client, I specified a few of the criteria. There are major four criteria. Will explain one by one. Energy efficiency, lifespan reliability, reduction of manufacturing inputs, recyclability. So as far as the first criteria, energy efficiency, how it should be applicable to the thin client or thin computing. Can thin computing significantly lower an organization environmental footprint by reducing energy consumptions and CO2 emissions during the use phase? This is the exact requirement under the energy efficiency. As far as the lifespan or reliability is concerned, how does the device longevity affects environmental impact? Uh, Next is reduction of manufacturing inputs. Does the smaller size of thin client affect the material and energy needed to produce and ship computing equipments? And recyclability, how do thin client and PCs compare at end of life? Now let us move to the comparative benefits of thin computing. In this diagram, there is a comparison of PC and thin computing energy consumption, electricity cost, and CO2 emissions. That means we are going to compare the PC and the thin computing in terms of energy consumptions, electricity cost, and CO2 emissions, which clearly indicates that this analysis illustrates the significant impact that thin computing can have in terms of energy cost saving and greenhouse gas emission reduction. So there are average power consumptions per year, and operational phase over 5 years that we have considered for all types of thin client, whether it is a 32-bit client, 64-bit client, thin client. We have considered all this. That means the additional server burden in a thin client computing environment has been taken into account where appropriate for all power modes below, as is typically run continually regardless of the client power mode. So we have considered everything, and after that we are going to compare all this. Now next is, that is, comparison of PC and thin computing material consumption due to lifespan and reliability mode. On average, thin client lasts twice as long as conventional desktop PCs. A PC is typically considered absolutely after just 3 years because of the advances in computing speed, storage capacity, and hardware or software functionality based on that. By contrast, because thin client has no hard drive and host no application, does not outlive its usefulness in the same time period. Second thing is that in a large number of moving parts contained in PC leads to a greater chance of mechanical failure. With no moving parts such as disk drives and fans, thin clients tends to have a lower failure rate. So this is that many impact of this thin computing. Second thing is that thin computing compared to the PC is the average of thin computing is thin client is approximately 25,000 hours. This results in a longer lifespan for thin client, typically 5 to 7 years. Another consideration directly related to the higher reliability of thin client is the reduced carbon emissions from transportations, parts and unit shipment for off-site repairs due to fewer lifetime service incidents. Environment benefits occur from this extended lifespan, both in terms of production inputs and waste generation. Based on the assumption of replacement rates noted above and assumed average weight of 24 pounds of desktop PCs and 6 pounds for thin clients, an 82% reduction in material is predicted. So we have calculated the reliability, and the total weight over 20 years is equal to the average weight per unit divided by replacement schedule x installation size x 20. So we have considered this. Now a reduction of hazardous and raw materials. Manufacturing a single computer require raw material, metal and fossil fuels, water, electricity and chemicals. The fewer components a device contains, such as in case of thin client, the resources that are typically used. A reduced number of components also require fewer electromechanical connections. So thin client approximately uses 60 to 70% lighter. It is approximately 60 to 70% lighter in weight and smaller in size than PCs. This directly affects the transportation needs and associated CO2 or greenhouse emissions. Due to their smaller size, more thin clients can be shipped in the same container, lowering fuel requirements and the environmental impact per unit shipped. Smaller items also require less packaging, which both consumes raw material resources and energy, contribute to the generation of solid waste. Now next criteria is that recyclability. All computers contains various levels of heavy metals and flame redundancy in plastics. The reduced number of internal components in thin clients directly results in few hazardous material to be disposed at the end of the product life. So modern recycling operations are typically able to recover greater than 90% of thin client device components for the secondary metals and the recycled markets. In economic terms, smaller size of thin client noted above result in lower landfill taxes on hardware disposed. Although per pound cost to dispose of non-CRT waste can be relatively low in some of the country, that is, I have considered in North America, as per the in the article it is mentioned. So I have considered here. And global warming potential, and it is useful to compare the alternative across all phases of product of life cycle and against a common metric, that is a global warming potential shows most CO2 emission occurs during the operating phase, typically due to the consumption of energy that is associated with the green gas emissions. Depending on the mix of energy generation sources, various contribution from natural gas, fossil fuel, nuclear or renewable energy, the CO2 emissions output may vary. So here we are considering relative contributions of global warming potential of thin computing and desktop PC across life cycle phase. So with this diagram, it is clearly indicate how the thin client is better than the desktop and the server. So as a case study, I have considered the Dell. The Dell having the thin client model is WYSE 7010, and as per their report, it indicates that the carbon footprint is 103 kg CO2 e plus minus it is considered, and up to it is 40 kg it is to be considered. So that is to be considered under the the production of the Dell machines, from design to end of life and everything in between. It is necessary to improve the environmental impact of the product whenever we are going to purchase. As a part of that process, there is it is necessary to estimate the specific impact throughout the life cycle, and this includes the contributions from the materials, manufacturing, distribution, use and end of life management. All these four things are very important when we are calculating the impact throughout the life cycle whenever we are going to purchase any product. So we have to be very sure when we are going to purchase any product. So again in the graph, the estimated impact by life cycle stage with breakout for manufacturing by component we have described here. That is use 54%, manufacturing 44%, and 22% electronics, PSU, assembly, packaging. All this how it is to be impact the throughout the life cycle. Dell uses the product attribute to impact algorithm to perform the product carbon footprint. It takes into consideration the important attribute of the product which can be correlated to activity in order to calculate the product carbon footprint. As a part of the commitment, this chart has the Dell has to be described that is right demonstrate the degree of uncertainty that exists within the model, that is product attribute for product carbon footprinting based on the assumptions we have, whatever we have decided the variables. The assumptions that we are considering is that what is the product weight, screen size, locations, product lifetime, assembly locations, energy demand. We have considered this. So this is the future of the that is after few years green computing, that is a 5G green, that is the development of energy consumptions for green communication. And here I am showing some important goals of environment, sustainable development environment, and the references that I have used for describing my topic. So with this I conclude that thin client is very important for us. Right now we are using the machines instead of higher end machines. If it is not required, use thin client and maintain the computational sustainability for under the environment sustainability. Thank you so much. So I quote that: go green, think green, and adopt the green IoT solutions for making our world smart world. Thank you so much.